okay? So yes, you could use the quadratic formula on it, okay? I prefer factoring because it's a lot quicker, like in the vast majority of the cases. There is, we'll talk about in a few days, what's called the cubic formula. Can anyone guess what the cubic formula would be? Yeah.
The quadratic formula for cubic.
Yeah, they have like an A, a B, a C, and a D. You plug it in, you magically get solutions. The problem is, it is the size of, if I were to write it at size 12 font, it's like, which is this big, it's about this big. Like this. So that's why we don't actually teach it in high school, right? But what I'll probably do is on your ISU, I'll put like one question saying, write out the cubic formula and use it to solve this. Okay, right? And you can use Google and all that and do it, right? Okay, so that'll be an option. But they are much more complicated to do. I will show you how to factor things properly, though, in this class to not use it. So, enough stalling. Tristan, what is the first step here to do factoring this one, please?
Well, first step is factor out, say, negative 2x squared.
Just 2x is probably good. Okay, what's left inside the brackets?
X squared.
Yeah.
Negative x.
Yeah.
Minus 12.
Yeah. Just minus x, not minus x squared, right? So that's right. Okay. Now, this question is big. Okay. I showed it to my grade 11s today, and they were terrified of it too. All right. So there's two ways to do this. Caitlin, what's the M and the A for this question, please? Good. Okay, now you can write out all your factors. Okay, so you can do 1 times 240, 2 times 120, 3 times 80, and all the way down. That takes a long time. I'm going to do it a quicker way. What does A negative 1 mean? What does that mean? Yeah.
That the two numbers are a difference of 1.
Yeah, the two numbers of a difference of 1, right? So you can either do like, 10 times 11, 11 times 12, or what I always do is I just take the square root of 240. Can somebody please tell me what the square root of 240 is? 15 and a bit, probably 15.49, probably, okay? So what, I did this with my class this morning, that's why I know that number, okay? So I can almost guarantee it's going to be 15 and negative 16. Can you guys just make sure that's what it is? Okay? That's a quicker way to find it. But the logic that I use is the gap is 1, right? So you could have done like 12 times 13 until you get the numbers to work out. Okay? Now, what Mr. Lacey used to say when he was still a teacher was if you can't find the numbers in about 30 seconds, go to quad formula. Okay? And you guys are in advanced functions, the same thing, right? If you guys can't get the numbers, do it. If I tell you to factor a question and use the quadratic formula, can you guess how many marks you will earn on the question? 0 is the correct answer. Okay, right? So why am I so negative? The point is what I'm trying to say. If I tell you to factor, all right, so you got to practice it. Okay. Joseph, what do you do with the 15 and the negative 16, please?
You put it in the in the brackets.
Go ahead.
The brackets would be 20x squared plus 15x minus 16x and minus 12.
Great. Awesome. Wonderful. Tremendous. All right, Robin, what do you do next, please?
Wait. Okay. Do I put 5x out?
Yeah, good.
We're supposed to be 19
And then 4x plus 3. Now, I'm not sure if you know this, but Robin has a 100% in her course so far. So I guarantee that she has factored properly. Why else is this factored properly? Go ahead. Brackets have to line up on all this. All right, Matt, what is the next step for this, please?
2x bracket 5x minus 4 bracket 4x plus 3x.
So 0 equals 2x. 5x minus 4x plus 3. Okay, so if you remember yesterday, this is a cubic function. I know it's a cubic function because of that 40x cubed thing. Okay? What did we say the most number of x-intercepts you can have is for a cubic function? I don't remember. One person. Go ahead. 3. So we're going to have 3 x-intercepts, and that's good. That's fine to do. Okay? Can someone be brave and remind me how to find the x-intercepts from right here? Joseph, go.
We can like take each individual bracket and make it that bracket equals 0.
Wonderful, okay. So we're going to say either 2x equals 0, 5x minus 4 equals 0, and 4x plus 3 equals 0. So we're going to say that x equals 0 is one possible answer. I'm going to say here x equals 4/5. I'm going to say here x equals negative 3/4. Okay, there was a question in last night's homework that made ask you to graph a cubic. I'm going to talk about how to do it using factoring. If you ever get stuck on your homework and it says graph something, what is your option if you're unable to do it, if you don't know what to do? What's a good option to try? Okay, go ahead. Desmos or a graphing calculator or a graph program or something. Somebody even told me table of values they used. That was awesome, okay, right? So that's going really old school back to table of values to do, right? But if you need to just do a quick sketch to sort of see, we're going to talk about how to graph something of this form today, all right, to see how it goes. Are we okay on the factor, what happened here for the factors and the roots? Oh, I sense no energy. I'm sorry you hate this course. We're 4 days in, don't hate this course, okay? All right, let's go through 8, 9, 11, 12, and then we'll continue on here, okay? So this is from last night's homework. If you're done it, great. If you got stuck on this, we'll go through it right now. Okay, so this is on page 28, number 8. It says, a snowboard manufacturer determines that the profit in thousands can be modeled by the function p of x equals x plus 0.00125 x to the fourth minus 3, where x is the number of snowboards in hundreds, and p of x is the profit in thousands. Now, I'm sorry about that. The question gave you the hundreds and the thousands just to make it sort of applicable, okay? But that really makes the solving of this more difficult than it should be, all right? Now, looking at this function, as a math teacher, I want to do one change to it instantly. Can somebody tell me, please, Albert, I'll pick on you. Is there anything looking at that p of x thing that makes you unhappy looking at it?
Decimal point.
Decimal point is, yeah, oh, for me as a teacher, I hate that. I don't know if I'm going to touch that yet, though. Is there anything else, though, for anybody here? Yeah, go ahead, Brian.
The x to the power of 4 isn't first.
Right. It's not in descending powers, right? So if you take a look with the x first, it makes it confusing for all that, okay? So I'm just going to rewrite this. I'll do my solutions in green. I'm just going to write it as p of x equals 0, 0.00125 x to the 4 plus x minus 3. And it's just good habit to write it in that thing, okay, that way. So it says, what type of function is p to the x? Is p of x, okay? Well, how do you find out what type of function it is? Callan, go ahead.
Based on the power.
Yeah.
So it's quartic and
A is going to be a, yeah, right on. A is going to be an even quartic function. Okay, now, all the rest of that stuff is going to affect it, but the main shape is going to be based on the even quartic. Can someone tell me, I don't know if it's asked on this or not, oh, that is part C. Without calculating, it says, determine the finite differences, which ones are constant. Now, this is the part that I want to make sure everyone understands. If you are tuning me out and wishing it was Saturday, it's not Saturday, okay? But this is the point of yesterday's lesson that not everyone got, I don't think, because this is the main thing. So, Tristan, this is it. It says, looking at this, what difference is constant? First, second, third, fourth, fifth, sixth, seventh. How do I know? Fox.
Want to be fourth.
How do you know?
The Quartic.
Yeah. You look at the highest power that's there, and that's what difference is going to be the same. Okay? So for letter B, you can say the fourth difference is constant. And no work has been done yet. Are Are we all okay on the logic that I used there? Because that was supposed to be the basis of yesterday's lesson. I got a lot of questions, which means I didn't explain it well enough, and I'm sorry about that. Okay, right? But that was supposed to be the main thing. Letter C says, in behavior, I have a positive quartic function. I'm passing you right yet. Okay, sorry. Atlanta, go ahead. What's the end behavior for something that's positive into degree 4? Go ahead.
When x goes positive, y goes positive, right?
Okay. I'm going to use infinity rather than forever, but I know what you mean. Okay.
And when x goes negative, y goes positive.
Okay, I want you to try and use the word infinity next time if you could. Okay, that would make too much after than I am right now. Okay. All right. But the point is, this is going to look like an x squared, like a parabola, right? It's positive parabola. The end behavior is going to go up like this. Yeah, go ahead.
Whenever it asks for end behavior, do you want us to do that and saying what quadrant it goes to?
Yeah, if you want to do that too, that'll work fine. As far as marks on your test, I can live with this. Okay, if you want to say either way works out from quadrant 2 to quadrant 1, either way, yeah, that's I can live with this. One that says state any restrictions on the domain. Oh, this is tricky. Are there any restrictions on the domain to a quadratic or a quartic? Okay, you should be jumping out of your seats at this. But were there any restrictions on a quadratic? Yeah? Who said yeah? What's the restriction on this?
For the x.
Yeah, for the x. Yeah, no restrictions on x, right? So for D, I should say, right, x goes on forever, right? E. What do the x-intercepts represent? What are the x-intercepts going to be? This is just what I was talking about here. Peter, go ahead.
It's like the break-even point, so just from the profit.
Yeah. So x-intercepts are no profit. Or break even, no profit, they mean the same thing. And F finally says here, what is the profit from the sale of 3,000 snowboards? Okay, so this is the part that was just getting tricky here. I want to sell 3,000 snowboards. How do I use my equation to solve that? Albert, go ahead.
You're planning for x.
Yeah, okay. So I want 3,000 snowboards. What's x going to be then? 30, thank you. Okay. So P of 30. I don't know what I don't really want to work out from the head there up there. What is it? Did you get that, Peter, for that?
Yeah.
What is it? Go ahead.
Zero. Oh, I got 1,039.5.
1039.5. Okay. Someone other than Peter, what does that number actually mean to me for a therefore statement? Well, play along, please, guys. Okay, this is going to be a long semester of just me and Peter talking. Please play along. Callan, go.
Does that mean stores that's how much you make? Is that the profit?
That's the profit, yeah. Okay, but almost so. The profit isn't going to be 1,000. What's the profit going to be, Brian?
You gotta multiply it by 100.
By 100. Is it 100 or 1,000? I think this one's 1,000, right? Profit's 1,000. So it's going to be times 1,000, right? Therefore, profit. Therefore, the profit is 1,039,000. Are we okay on the logic from A to E there, right? Because it's the A to E part that I'm concerned about. Riley, how you feeling? Right? Even though I have no head in my hair, you're okay with this? Yeah. This isn't the time. Oh. Yeah. Okay, so what am I stepping in 30? Let's get the old calculator out. Oh, I don't have a calculator there for some reason. Okay, so the comment was I got a different number. I'll see what I can do here. Where's my calculator? I'm sorry, I can't find my calculator on here.
Not sure what
Did anyone else get 1.039? Did anyone get 1039? Did anyone?
Yeah.
Yes? One person did? Okay. I trust you two then. Okay, so for those who are just joining us here, I'm just basically going through the homework from last night for that. Okay. Which one do you guys want to do next? 9, you said? 9A? Okay. 9B couldn't do it, said graph, using graph and calculator regression. I'm going to leave that. I'm much more interested in 9A, okay. All that 9A is the difference table. Okay, so this was time and time displacement. Now, one of the things that makes these awesome questions, or at least I consider them awesome, is that you can't tell just from looking at it what the equation is going to be. Okay, like if you remember how we looked at the table for parabolas, you'd see one side would be going up to a point, and all of a sudden they'd be coming down, and you could see it, right? Well, here if you take a look, it gets up to 40, it gets up big, it's going 10, 36, 42, 46, and it jumps up again. Like this is, the table is going to be sort of a curvy sort of thing here. If I had to guess, this is going to be cubic, just looking at it, okay? Like it's getting big and then it slows down, then it gets big again, okay? Just looking at the numbers. But it could be to the fifth as well, too. It's got to be something. That's my guess, all right? So this is what we did yesterday. I'm hoping everyone can do this. I'm going to do this at 100 miles an hour, if you don't mind, okay? Because this should have been the easiest one from last night, the first half, all right? So 34 minus 10, so I'm going to do first difference was 24. Then that's 8, then that's 4, then that's, what is that, 12? 32, 86. Oh boy. Whoa, 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 goodness me. And what's this, then 108? Is it better now? Now we're better. One mistake, oh my goodness, all right. Second difference, okay? Okay, so that's going to be negative 16, negative 4, 8, 20, 32, and oh boy, 44, is that right? Okay, third difference is 12, 12, 12, 12. Okay, what they wanted you to do for the rest of the question was to calculate the A value. Is that right? That's the rest it was. It should have been. Okay. Can someone remind me, Peter, you're out. I'm sorry, Peter. We'll be back in a minute. How you calculate the A value, please, for this one? Yeah, go ahead. Yeah. Factorial. Yeah, 3 factorial. Can someone be brave and tell me what 3 factorial is equal to, please? Tristan, go. 6. 12 is equal to 6a, a equals 2. Okay, so what is the first term in this equation? What's it going to be? Go ahead. 2, yes?
2x.
2x cubed, right? Okay, now this is the thing I maybe didn't explain well enough yesterday. The rest of the equation's there, but it doesn't really affect the shape. The leading term is what tells you the end behavior and the overall look. It's the 5x squared and all that puts all the curves and all that stuff in it. Okay, right? It's just the x cubed affects the end behavior and stuff like that. It's the plus x squared plus x in the number that's going to give all the bumps and all that along the way. Okay? That's what I was hopefully trying to say yesterday. It didn't happen, I don't think, but that's what I was meant to say. Okay, this should be good, I hope. I'm hoping it's good. Matt, you're fine? Okay. Question?
Just for the next one.
Oh, 11 it says? Oh yeah, the regression I'm going to skip. Sorry about that. That was not meant to have been put on, okay, because I don't expect that. You guys with the powers of technology should be able to find regression, hopefully on the web, but if you couldn't, that's fine too. Okay. 11 we're up to now? 11. Okay. Please put a star in the heart beside this question. Okay, if you haven't been in my class before, a star in the heart means you're going to see this on your test, or it's very important, a fundamental, important part of this course. All right? So number 11 says, the volume V in cubic centimeters in a collection of open top boxes can be modeled by V of x equals 4x cubed minus 220 x squared plus 2800x. This may look familiar to you from the warm-up, where V equals volume and x equals height in centimeters. A said graph V of x. Okay, and this is, I think, what was scaring some people. Okay, they got to this and said, yeah, I don't know how to graph a cubic. Okay, and that's okay if you did. Okay, so let's do this one at you and see what you could do with it. Okay, so there are two options here for this. Okay, to graph this. Option number one is to grab Desmos or a different graphing calculator and sort of base your sketch on that. Okay, what would the second option that we could do here be? Go ahead.
You factor out the 4x.
Okay.
And then you find your root.
Good. So what we're going to do, we're going to say to graph this, use your roots and the end behavior. Okay, so I hope you don't mind, I'm going to embarrass you for a second, Alana. Alana came and did a great job in her graph, and she got the roots in there, but she said, how do you know which way the bumps go? That's your exact words. I believe that's your exact words, right? How do you know which way the bumps go in the graph? And that's the end behavior. So I'm going to start with the end behavior, then we'll go backwards here. Can somebody tell me for this, if I have a positive cubic function, how am I going to, what's the end behavior of this going to be, please? Right, Dexter? Quadrant 3 to quadrant 1, okay? I'll write it as x goes to infinity, y goes to infinity, as x goes to negative infinity, y goes to negative infinity. Okay, if you don't have this committed to memory of how it looks, remember, even functions look like parabolas, right? Odd functions look like lines, right? For that. Are most people okay with that, what I just did there? Okay. I'm going to hit, sorry, go ahead.
How did you know that was
Oh, okay, this is, because this is, if you just look at the first term, it's going to be cubic, right? So we said cubic functions are going to be odd functions. All odd functions look like that first line. Remember the first day we were doing this is y, that's y. So going back to our quadrants. On the left-hand side of it, it's going to be down that way. Right-hand side is going to be up like that. Okay, I'm going to hit pause in the video. And while I'm pausing, you guys should factor that and find the roots if you haven't done it already. If you've already done it, that's fine. If you have not, do it right now. It'll take him a second for this to stop here, okay? 23 minutes.